Hello, my name is Eric Berger. I'm the CTO at Desmos.com. Desmos is an online graphing calculator, and today what I'd like to show you in this webinar is one of the features that we've released recently and very excited about, which is tables. This is the third in our series of regular webinars. We're doing them every couple of weeks. You can find them on our Desmos Inc. YouTube page. If you're watching this live and you have any questions, just tweet at Desmos. And I'll try to answer them as they come in. If you're watching this recorded, probably you shouldn't ask any questions live, but still feel free to tweet questions. We'll get back to them as we can. So I'm going to start by showing you Desmos.com and what you can do with tables here. So what we have here is the front page at, or I guess not the front page, but the calculator page. If you go to www.desmos.com/calculator, you'll find yourself here. For those of you who haven't used Desmos before, just a brief overview of what we have here is we have graph paper, where things can be, where you see graphs. We have an on-screen keyboard if you're on an iPad, or if you prefer to use it for things like square roots. I prefer to use the keyboard. You can use either way to edit things. And we have the expressions list on the left. So the basic way that Desmos works is you can either do a computation, something like 1 + 2, you'll get the answer that it's 3, or you can type a function like x squared and see a graph. You can zoom in and out, and you can sort of observe and analyze what looks like it's going on in that function. If you're interested in these, I recommend, if you haven't seen Desmos before, I recommend you check out our other webinars and check out the information we have available on Desmos.com. So what I wanted to talk to you about today was to show you a new feature, which is tables of data. So first, I just want to show you where you can find these in the UI. If you followed along, if you're sitting here at the calculator, what you're going to want to do is look at this, this little button right here, which will bring you out a tray. This drawer shows you the different kinds of things that you can insert into the expressions table. Expression will just insert you an expression like the ones that I was just typing in. That'll let you do a computation, or will let you graph something. Text will let you say, here is my table. This is very useful for creating labels. Or if you click table, you will insert a table into your graph. So this table probably looks relatively familiar. This is very similar to what you might draw up on a chalkboard or a whiteboard if you're teaching your students, what you might put into a worksheet. And really our goal with developing it was to create something that was as flexible as a whiteboard or pencil and paper, and really let you use it in all the ways that you might want to use it in a class, but that was also tied together to the power of a graphing calculator, and would allow you to explore functions and to explore data in a more interactive way. So first I'm just going to talk through the basics of what you can do with a table. What we have in the table here is we have our column headers, X and Y. We have one row of data. I'm just going to go ahead and click in this cell and enter 2. And you'll notice that immediately we plot our point 1, 2. If we enter another data point, we'll plot that point next. So a couple things that I wanted to bring your attention to. The first was how I'm navigating. So you'll notice that when you're inside the table, you'll see an extra sort of partial column to the right, and you'll see an extra partial row to the bottom. The way that those work is if you want more space in your table, just start using it. When you click in one of those cells, you'll get extra space, and you can just use it to either add a new column or to add a new row. Also, while you're in the table itself, if you hit enter, you'll create new rows. And if your initial variables, if your initial values lie as part of a linear series, we'll just go ahead and continue to autofill that for you. But if you're not interested in linear data, you can go ahead and update those values to be whatever you want. So you can type in explicitly sort of whatever information you want, just like if you were filling out a table with pencil and paper. So the simplest way that you can use a table is to do basically what we see right here, which we call an independent column. So we have our x values. I'm just going to go ahead and fill in 1, 2, 3, and we have our y values. And it's up to you to fill these in yourself. So say we want to plot some kind of a linear function, and we just go ahead and we type 2, 3, 4. We've got a couple of points here. You can see that they're shown on the screen, they're shown in the table, and this is something where if you save this and you send it out to your students, they'll be able to have that graph, or it's something that they can turn back into you. When you have this, there's a couple of options that you have here. If you click this icon, it will open up the table menu, and it will show you what you can do. You can insert additional columns. You can change the color of your points. Say we go with orange. Orange is a nice, beautiful color for a point. You can decide that you don't want to plot them. And this can be very useful if you're doing an exercise where, for example, you want students to compute a number of points, predict what the function will look like, and only then plot it. Or if you want, you can opt to connect your points with lines. So as an example, let's say that we want to have our students compute a linear function. We say, here's our x values, 1, 2, and 3. We want to compute the value, say, x plus 1. So your students, here's in a table, fill it in with values of x plus 1. I'm going to say y equals x plus 1. So you have this table. You can fill it in with values y equals x plus 1, and then you can say, where do we think that's going to show up on the graph? When you go to show it, then you can display. That's useful. One of the things that makes tables here really unique. So you start to see an advantage of a Desmos table over a pencil and paper table right here, where you can say show, and it will plot the points for you. One of the things that we think makes Desmos tables really unique is that they're tied into the full power of our evaluator. So for example, if you wanted, instead of saying, instead of filling in x plus 1 yourself, if you just typed in x plus 1 in your top header, the system will fill those values in for you. And so now as you add additional x values, you will both populate your table and populate your graph. And it's a really good way to sort of build a function input-output table where you can define whatever function you want. If you're interested in a more complicated function, you can either write it up in the top, or you can define, say, f of x equals sine of x, and you can just go ahead and write that up in the top of your function. And so that will allow you to basically sample points from any function which you have defined in a worksheet, defined in some kind of a graph that you're using. So that's the way that we do our basic, what we call dependent columns. So the next thing that I wanted to show you, which I think is really fun, is that you can actually you can combine these together. And so for me, the thing that I always think of when you're combining these together, and the thing I think of with tables of data in general, is how do you use that for modeling. So I'd like to go ahead and clear this out and sort of talk you through an example of how you might use this to run a modeling exercise in your class. Right? So let's use, for a concrete example, a modeling exercise that we've worked together with Dan Meyer on, which is called pennies. Basically, the way that this exercise works is you show students a variety of circles from large to small, and you ask them to fill them up with pennies, and use that to predict how many pennies would fit in a very large circle. So as your students do that, you go through the process of gathering data, then you go through the process of plotting that data, you come up with a model, you evaluate how the model fits, and use it to make a prediction about the world. And I sort of want to show how you might use a table to support that in a real-world example. So if you're going to start that out, we have our x and our y. Let's say we want to go ahead and we want to change those. We want to have this be the size of the circle. So we're going to have this be the radius of the circle. And so we're going to go ahead and have the size of our circle, and we're going to have the number of pennies. We'll start with the freebie point, the circle with no radius. We have no pennies in them. We'll make, say, our circle of size 1, and we'll have 1 penny in it. And then, as we gather some data from a few more circles, I'm just going to put in sort of our imaginary data here. So let's say that that's the data that we get as we try to put our pennies into the circle. So the first step, we can use Desmos as a way to capture our data, a way to write it down in sort of a nice, clean organization, sort of define our variables, discuss what they mean. As a second step, we go to look at what does this mean on the graph? What does this curve look like? And so we can zoom to the point that we really sort of, we can see all of our data points, and we can say, what does this curve look like? Does it look like any curves that we've seen before? Right? And so maybe you'll think it looks like an exponential. Maybe some people will think that it could look like a quadratic, right? It looks like the right half of a parabola. Maybe somebody will think that a line is a good way to match that. And so what we can do here is we can go ahead and write our estimates just as very basic equations and watch how they relate. So say we wanted to do a very simple linear estimate. We said y equals 5x. We think that's too high. Jump that down to y equals 3x, y equals 2x. Since Desmos supports sliders, and a bunch of you have seen this, you would probably say, let's say y equals mx, and adjust our m, see if we can get this line to really like move through our data. We notice that as we adjust that m, we really can't get a very good fit to the data. So maybe you discuss the problem and you decide, okay, what if we think that this is a quadratic function? What if we think it's something, ax squared plus bx plus c? Right? And maybe you have a discussion, you decide that because it goes through 0, you're going to get rid of your c. You create your variables, and again, you try to adjust them, and you say, can we make this go through? So as you do this, you can create your model, you can see how it compares to your data, and it's easy to see sort of in a visual sense how they compare. But what you're really going to want to do next is discuss in a numerical sense, how does your model compare to your actual data? And so that's one of the places that tables are really exciting. When I said we could mix the independent and the dependent forms. So we have an independent column here. We have sort of a discrete column that's been edited here, that's sort of been added to. And now we have an additional column here, where we can actually show what our estimate is for this penny size. And this will show here are our guesses in brown versus where our actual measurements were in purple. Or we can actually show what is the difference, what is the residual, what is our guess minus our model. And so these brown points now will actually show us how is our model doing. Is it accurate, is it not accurate? And as we adjust our parameters, we can play with this and we can sort of talk about, okay, what does our error look like? What do our residuals look like? We can zoom in and we can both look at it in a graphical sense here. We can also look at it in the table sense. We can say, okay, here are our errors. These errors all look like they're less than a penny. So an error of less than a penny, what does that mean? Is that an error, or does that mean there was less than 1 penny to fit in? Right? So this is a very good way to move from the general intuition that you want your line to go about through your points to actually say, for each of these points, what did we predict and what did we actually get? If you decide that this is sort of too big of a step, you can go ahead and use 2 separate columns to really make it obvious where the subtraction is happening, right? We measured 1, our model predicts 1.03, here's an error of minus 0.03. And that's definitely useful for being able to sort of show in the context of a table, here was our data, here was our estimate, and here's our error. One of the things you'll notice is, although we have sort of all of these various components here, we have our entered data, we have our data with parameters, everything throughout the Desmos system is all connected to the same underlying set of parameters. So even once this is here, we say, we're really, this error on our 4th data point, this error on our 5th data point, where our size is 4, is something we're unhappy with. So let's say we want to go ahead and adjust A and B and really look at that particular data. All the information in the table adjusts as you adjust your parameters. Or if we decide we want to set B equal to 0 and play with our A and see how well we can get it to match. Again, you can sort of see exactly what's happening as you move move your parameters, and you can see how your residuals are affected. and maybe you come to the conclusion that you're able to match everything except this last point, and maybe you should go back and re-observe how you measured the point or something else like that. So that's sort of an example of how you can use tables in your classroom to take the sort of this kind of modeling exercise and really break it down into what the various components are. What's your data? Where did it come from? What's a model? How can you compare a couple of different models? I'd like to show you a couple of the other things that tables can do. One thing which I found is they're useful for is when you've written up a function, right? So we already have our sine of x minus a, right? So we have our function here, and you want to look at it. Say you'd like to put this in a table. In the edit menu, you'll find this tool here, which is convert to table. If you press that, your initial equation will turn into a table equation. So you can either show or hide the curve, show or hide the points. So you can go directly from that sort of continuous functional form that you're used to with Desmos, where you write an equation, we plot it, to something where you can then open it up and say, I want to have a couple of sort of sample points, either to use this to label the points of interest that you care about. For example, on a, let's go ahead and simplify this, make this a sine of x. Maybe you care about what are the values at minus pi over 2, 0, pi over 2, and pi, right? So those are a number of points that you care about. And this lets you really look at, like, okay, here's sine of x, and then to compare that, here's cosine of x. How do those two compare to each other? Maybe you want to show the curve so you can see both of them, or maybe you want to take off both of those curves. This is a great way to sort of be able to put two functions side by side and say, okay, what does the value look like at minus pi over 2, 0, pi over 2? Great for comparing quadratics or linear functions, really nice for comparing trigonometric functions, and it also lets you start at this point and then go ahead and sort of add your connections so that you can go from just looking at an understanding of the special points to actually see exactly what it is that's happening here, and then go back to the table and say, oh, it looks like everything for cosine of x is just shifted up one row. If we went down, we did 3 pi over 2, we would again expect to see that these values are shifted up one. And so you get an understanding of the phase shift between sine and cosine, or something like that. So finally, one thing that I wanted to show with tables, which is just sort of fun, is because of the fact that as you enter your data, you can choose to connect the points to each other. You can use this as a way to do simple drawings. A lot of people do drawing with Desmos, and right now this is actually a very simple way to create line segments that go from one point to another. So this is definitely another thing that you can use tables for, either create a collection of points or a collection of lines, put in your coordinates, and sort of say whatever it is that you want to draw. Say you want to draw a Christmas tree or a boat or whatever that is. This is a great way to say, here's my set of points that I want to enter. I want to go, say the Christmas tree, 4, 3, 3, 2, 2, 1, 1. Right, you build your tree. So this is definitely, if you're teaching your students just sort of to interpret what coordinates are, what they mean, and you're using math art as a way to motivate that, this is a more accessible format for drawing out a set of points than the piecewise notation is that you sometimes see people using. So you can either do this or you can use it just to draw a set of points and discuss what they are. That's a final use for tables that I found really interesting. So at this point, there's a lot of other places we could go, but I thought it would be most useful to open up and ask, are there any questions on table usage or how you'd be interested, anything that anyone would like to know about tables? Okay, so question about how to use this on touch devices. Great question. So if you are on a keyboard, the best way to navigate through a table is using the arrow keys. From where I am, I'm hitting the right arrow, left arrow, down arrow, up arrow, enter to move through. That's great and intuitive. If you're on an iPad, you don't have any of those tools. So what are your best options? There's two good sets of options for what you can do when you're on an iPad. One is with these partial table cells, you can click within them to put focus. So you can click here, you can tap with your finger, and then use the on-screen keyboard to enter a value. You can enter here to type 11. The other option is within the on-screen keyboard itself, we actually have delete, enter, and arrow keys. A lot of the time people don't notice this for use in the regular expression list, but within tables, because moving around is so important, those are just something that I wanted to bring your attention to. So those will work to move you down, move you up, and really let you move around within your tables if you're on a touch device. So I wanted to thank you for your time. Thank you for taking the time to come watch this webinar and to learn about tables on Desmos. Feel free to tweet at Desmos or send us emails with the feedback form on the site if you have any questions about tables, or if you want to show off something really interesting that you've done with them. We're really excited to see how our users are going to use this new feature, and really want to make sure that it supports your classroom practice as well as we possibly can. So thank you very much.